Once again, you're most welcome to this channel. So we're going to also look at the R formula under trigonometry by these two examples, part A and part B. So under our formula, we are solving problems in the form of A cos an angle plus B sine the same angle. And our target is to write now this in the form of 1:3 ratio. And normally we have, or we get a certain constant which we call R to that trig ratio, but to a certain angle, and this angle is the sum of our angle in play and some other angle generally. But this can be a cosine or it can even be a sine. So it is done in accordance to what we are having, because we know what we get on expanding this. On expanding this, we should be able to get cos of this angle and sine of this angle in those positions. So that is the brief thing I can say, but now let us go into the details. Now under my part A, we are having 2 sine theta plus 7 cos theta being equal to 4. I will start by letting this quantity in this form. So this quantity is the one in this form. Our B is the 2, because this is now sine, plus 7 cos an angle. I will let it to be equal to R. And I will think about now sine, because it is sine of the sum of two angles, which starts with the sine of the same angle plus alpha. So we have chosen to use we have decided to use this one because on expanding this, we know it will start with this sine theta. If you're somehow confused, try revising compound angles under trigonometry. So by letting this to be this, we can expand now this, and this is sine theta cos alpha, and the plus also comes back just as this one. If this was a minus, we will use a minus. Cos theta sine alpha. So after this, we can write this 2 sine theta plus 7 cos theta is now equal to, I make this R enter, so it becomes this plus R cos theta sine alpha. And now we shall compare these quantities. This quantity is having a sine theta just as this one. Cosine theta is this quantity just as here. So we shall compare by equating these quantities. How comes that these quantities are equal? It is until the R cos alpha attached to the sine theta, it is until the R cos alpha attached to the sine theta is equal to the 2 attached to the same sine theta this side. And also, just look at this cos theta. It means the remaining terms, the R sine alpha should be equal to the 7. Should be equal to the 7. So after this, our target is to solve these two equations for the two unknowns, the R and the angle alpha. So the first step it is, I can use this one equal to 2, and by this I divide by this equation. I divide this equation by this one. So I get R cos alpha here, and this is the 7 and the 2 here. This will stay together. And the R here will vanish, will cancel. So this will become tan alpha equal to 7 over 2. From this I'll get my alpha as tan inverse of 7 over 2. tan inverse of a 7 divided by 2. So this gets me my alpha as a 74.05 degrees. So after getting my alpha, I also look for the r, and never use this alpha in this position for you to get r. Instead, we shall square both sides of this equation and also square both sides of this equation. So we shall get r squared cos squared is equal to 2 squared. And we shall also get this one as r squared sin squared alpha is equal to 7 squared. And we shall add these two equations. So by this I will get r squared alpha plus r squared sin squared alpha is equal to 2 squared plus 7 squared. So I pull out the r squared, I remain with the cos squared alpha plus sin squared alpha equal to, this is a 49 plus a 4, this is a 53. So according to our identity, we remember very well this is a 1. So I end up with r squared equal to 53. That's my r, is the square root of 53. Here I don't introduce plus or negative. We are interested in the positive quantity. So after getting our r and our alpha, we can now say that this we did let to be equal to this. We can now, instead of writing this, I will now write this in this one's position. So I write r sin theta plus alpha equal to a 4. And our r, we are having it as a root of 3 sin theta plus our alpha 74.05 degrees is equal to 4. And from this point, we will continue by dividing this on both sides. 74.05 degrees is equal to 4 divided by 53. And from this stage, we are not directly getting this angle. We are instead getting the principal angle, which will be the sine inverse of 4 over root 53. And now we shall get this principal angle as divided by root of 53, which is 53.33 degrees. And it is this angle which we shall now use in our quadrants to ask ourselves in which quadrant is the sign of an angle positive. And it will be this one and this one. So here is our 53.33. Also here we have our 53.33 degrees. So our first solution is this one, and our second solution is this one. But remember, principal angle was in here for this angle. So on extracting solutions from this one, our principal angle was in there for this one. We should remember that. So this is equal to, this is the 3 point, that one. And now this one, 180, 33.33 off. We also get it as 106.67. But now this is from 0 degrees. We are aware that at our next stage of getting the solution, we shall subtract this on both sides, and we shall subtract this to the left. We shall also subtract subtract the 74.05 on every angle which we are getting as our solution. That means it signals to us that when I go to my second circle or to an angle which is from 360, and now I measure this one from 360, I add this angle. In other words, the angle which is of this size, 360, but now the 33.33 added on. We get it as 393.33. Because we are aware that at the end of the day, to get our theta, we should subtract the 74.05 on both sides. So this one minus 74.05, 33.33 minus 74.05 gets us a negative angle 72. Also the 146.67 minus the 74.05 gets us a 72.62. And also our 393.33 minus the 74.05 gets us a 319.28. So by this we end up concluding our 72.62 and the 319.28 as our solutions. Because this one, it is not in the required range. The required range was 0 degrees to 360. Though this was not less than 360, we knew by this idea, we got an insight that it will reduce and become a required solution. So this is it.